everybody, it's Mrs. Pound, and we are continuing on with our chapter on weather. And today our topic is going to be on local winds found in section 5.2.3 of your textbook. So our objectives today are to summarize the nature of wind, compare the types of local winds in different geographical areas, and explain why meteorologists measure wind speed. So wind is formed by the movement of air from a high pressure area to a low pressure area, um, always. And so this is why air pressure, I talked about in class, is so important to our weather because it really affects uh, the movements of our weather and wind. Wind is very important to our weather. So always moves from high pressure to low pressure. There are a couple kinds of local winds. The first I want to talk about is a sea breeze. This is a local wind that forms during the day when cooler air over the water moves in to replace warmer air that rises up from the land. So, on the land heats up faster than the water. So, the land heats up, warm air rises, creating an area of low pressure. There's now higher pressure off over the water because the water is cooler, and so that high pressure over the water moves to the low pressure over the land, creating what is called a sea breeze. And the breeze is coming off from the sea, so that's why it's called a sea breeze. You'll also find this phenomenon around here at the Great Lakes and also on even Chautauqua Lake somewhat. Now, to go along with a sea breeze is a land breeze. Sea breezes are during the day. A land breeze occurs at night. The land temperatures drop more quickly than the water temperatures, and air from the cooler land is drawn to the warmer air over the water. So here, now the opposite is happening at night. Land cools down, that is colder, forming an area of high pressure. The water now is what is heating up the air. The air is rising over the water, so now the high pressure over the land moves to the low pressure over the water. So you now have a land breeze. The breeze is coming from the land. Now, what I want you to do, if you're listening, this will show that you're listening, draw a bracket between sea and land breeze, or even like a double arrow or something like that to show that these happen together. Okay, so indicate somehow that sea breezes and land breezes go together. Now, you will also find this phenomenon on Chautauqua Lake. Okay, my husband and I used to go sailing on Chautauqua Lake, and so early in the day there would be a breeze, which would be like a sea breeze. I guess you would call it a lake breeze in this area, and it was great for sailing. Around noontime or the middle of the day, there would be no breeze because by that time the temperatures have kind of equaled out over the land and over the water, and so there wouldn't be a breeze. And then later in the afternoon, the breeze would pick up again. Okay, or at night, you'd then have your land breeze coming in, but there's a time of day when there is no breeze because of what is happening with the sea and the land breezes, or what probably more a lake and a land breeze. Now, in the mountains, you have valley breezes and mountain breezes. So a valley breeze happens during the day again. The mountains heat more quickly than valleys, creating a low pressure area. The mountains heat more quickly because they're higher up. They tend to be more bare rock. They don't have the vegetation on them. The vegetation keeps the valley cool, so the rocks heat up on the mountains. The low pressure pulls the cooler air up from the valley. So you have high pressure in the valley. You have low pressure on the top of the mountains. Air moves from high pressure to low pressure. So a valley breeze, and during the day it's called a valley breeze because the breeze is coming from the valley, just like the breeze comes from the sea or the breeze comes from the land. It's named after where it comes from. Now, then there's, with the valley breeze, a mountain breeze. So at night, cooler, denser mountain air moves down into the valley. So at night, that rock cools faster than the valley, creating higher pressure. The valley's now at a lower pressure because now it's heating up the air more than the mountain. So you have that denser, high pressure air moving down into the valley. So you have a mountain breeze coming down into the valley. And here you would have that happening here because here are mountains, here's a valley. So you would have a mountain breeze coming down. Now, again, brackets or arrows or something to indicate that valley and mountain breezes go together. They work together. There's also another type of special local breeze called a Chinook. This happens over the Rocky Mountains. This is a wind that blows over the mountains, sinks on the other side, and produces warm winds. So, wind coming off the ocean goes over the mountains, cools when it's over the mountains, sinks, and makes a warm wind on the other side of the mountains. That is called a Chinook in the Rocky Mountains. There are also other areas in the world where they experience these types of winds, and of course, they all have a different name for them depending on their language geographically. And then I want to talk about an anemometer that we are using in class. And this is an instrument used to measure wind speed. You can see down here there are cups. And so basically this device measures how many rotations, and wind speed can be calculated from the number of rotations. The more rotations there are, the faster the wind is blowing. Okay, and so we're going to use an anemometer in class as well to do that, to measure the wind speed. We won't get an exact wind speed, it will be more relative, but we'll be able to see that the more rotations there are, the faster the wind is blowing. Now, meteorologists measure wind speed to predict changing weather patterns. Wind speed helps us to know whether there's maybe high pressure moving in or low pressure moving in, because our winds will, remember, it goes from high to low, so we can tell, okay, where's the weather coming from, so we can say what type of weather it could be. We're going to talk about that later in the chapter. Also, just a change in speed tells us that these pressure areas are moving, and it's going to bring in some different weather. So our objectives for today's video were to summarize the nature of wind, compare the types of local winds in different geographical areas, and explain why meteorologists measure wind speed. So don't forget your 5 questions, and we have a lot more to talk about with weather.